everyone, we will solve this today's LeetCode problem. The question is create binary tree from description. So this is a LeetCode medium one. So let's see what the question is asking. So we have given a 2D integer array description where description I is parent I, child I, and is the left. So the parent is the parent of child of a binary tree of unique values. So we have given a unique values of all these values. It means they are not there is no duplicate values in the trees. So if is left is equals to 1 given, it means this the child which is given in this description is the left child of the parent, right? And is left is equals to 0, then the child is the right child of this parent, right? And we need to construct the binary tree described by the descriptions array which is given and return its root so that they can see the output of this 5020, right? So basically the question is self-explanatory that we have given a description, and description the first element is representing the first element of description I is representing the parent I, right? Of description I is representing parent, second element representing child, right? And the third is representing whether this the child is either at left part or it is a right child, right? It is representing left child or right child, depends on the value 0 or 1, right? So basically we need to construct this binary tree. So one thing is for sure that if we see this example, that this 20, 15, and 1, so this 20 is this 20 this 20 is here, and 15 is given the child, and 1 is the left is 1. It means this is the left child of this 20, so it is connected to 15. Again for 20, 17 is a child, 0 is a is left is 0, it means it is a right child of 20, so it is marked as 17. uh, the same things again and again is repeating for this to make a graph, right? So but how we will make this graph, right? So basically if you see, the first is 20 and second is 15 and this is one indicating. So basically do we will simply do that which is asking in the question, right? We will move to its description part, and then we will just see this parent. Its parent is 20. Then what we will do, I will check for 20, then I will go to its child part which is 15, and this is 15. Move to child 15 which is in the left part, then again we will move to 20, so same 20 is a root, right? So it means we will just make a check, right? We will check that whether I have already we have already make a node of 20 or not, right? So yes, we have a node of 20, right? So what we will do, we will not make any extra node and we will just see for 17 itself, right? So we need to we will what we will do, we will check for each parent child, that whether we have already existing child and parent node or not, right? Whether we have already existing child and parent node or not, right? And if it is not, we will create that. If it is not, then we will create that, right? If it is already present, why we really next another node, because all the values are unique, so it's not optimal to make another node, right? If so, we will check that whether the child and the parent node is available or not. So if it is available, make uh, I will just assign this value 20 to at the right position to 70, right? Again for the same thing, 15, 20. So 15 is available, no, it's not available. So we will what we will do, we will make a 15 node, right? So we will make a new node 15. Its right value is its left value is 20, right? So we will check 20, yes, it's available, right? And from 50's left child is 20, so 50 is available and its left child is 20, so we will assign that. So just we will what we will do, we will just connect this two nodes, both the two nodes, according to this, right? Just we will connect this, right? So what we are doing, we are just iterating this and checking that whether we have the parent node exist 15, the child exists or not. If they exist, we will just connect both of them according to the left or right, which is indication of is left. And otherwise we will create one extra node if it is not created yet, and then we will connect. Ultimately we need to connect parent and child node, right? Either it is already created or we will create one, right? So that depends on is left value, that it is the right, it will connect to the right or the left, right? Now, so we will complete this, right? We will complete this. 50, 20, 50 is the 20 is the left child of 50, so we'll done that. 50 is again existing, so 50 parent is available. 80 is already it is a child, so it is not available yet, right? So we will create 80, and if we create 80, you see that it is at right position of 50. So we will do that, right? We will assign is 80 child to the right. Now we again move, so 80 is again a parent, so 80 child is already existed. 19, so 19 is already 19 is not there as a child, so we will make a 19, and it is a left of 80, so we will assign this left of 80 to 90, right? What we do. Let's make some spaces. Let's make spaces, right? And this is the 90, right? And if you see, now the question is how we will return 50. Here I can visualize that this is a 50, but how we will return 50 as a root node, because ultimately I need to return a root node, right? But how we will think that, how will we know that whether 50 is a root node or not, right? So one thing you see that the root node will never be a child node, will never be a child node, right? And all the values which is at present at 1th part at description I is a child node, right? So what if I just store all the child nodes in any keep a track of, so if I just keep track of all the child nodes which I get in all in description side, and I will iterate again in whole array. I will iterate again in whole children, right? I will iterate again in whole children's and a whole this children's part, and check that whether the node is in my children or not, in my children or not. So the node which is not present in children's part, children's map or something, you can take map or dictionaries in Python, a map in is Java and C++, right? So it is not present in children map, then you can simply return that value. I'm sure about that value as a root, right? Because I'm sure about that will be the root, right? Then return as a root, right? So this is how we will just solve this question. The question is very easy. Just you need to make some checks while iterating in this description, right? And you will figure out that how will this move, right? That's the question. We will just try to implement this, right? So the first thing is what we will do. We will iterate in this description part. So this is end, and the let's make this at this, right? This is very long, right? So this size. Now what we need to do, we need to keep track of uh, nodes, right? So for that, I will do, I will make a map of entry node, right? And the first, this is the mapping for the values to its node mapping, right? This is just a values map, right? Values node, right? And what we do, we will also to keep a track of the children's which we got till now, right? There are two things, right? This is child. Now what I will do, I will just iterate in this description. So the first thing is the child. The first thing is a parent, right? The description I is 0 is a parent. The second is its children's. So don't make this child, because this is also child. So make this as a visited child, right? This is a visited child, and this child is at 1, right? Also there is a left pointer indicating the whether this child will be at left or right. So description I two, right? These three things are. Now the first thing is parent and the child, right? So if parents and child is already made up, we will not create one, otherwise we will create one. So we will check that whether we have this parent or not. So this is valid dot count, and if it is zero, it means we don't have one, so we will create one. So for creating one, we will create one node, and this is new keyword. In Java and in Java and Python there will be a different for creating. In C++ we use new keyword, right? So this is a parent, this is the parent value, and we will create one. Now what we need to do, we need to store this in my map, right? This value node. So this will be a parent value, and this is the node. We will assign that. Same thing for child, right? Same thing for child. If the child is doesn't exist, we will create one. Otherwise, we don't create, and we will assign this to node, right? Now, this child needs to be connected to parents, right? But how we will connect it? So, okay, one thing is also that this child needs to be present in this visitor child. So this visitor child must be inserted in this part. This will be plus plus, right? Now this needs to be uh, attached to parents left or right, depends on this is left value. So if is left is one, so it means it's need to be at present at left part. So this value node is representing this node, right? So this value node, so that's what the reason of this making node, because it will create a mapping of this node. So whenever I want to fetch by value, and the values are all unique, so it will give me the unique node, right? So the value node of parent and its left will be assigned to this value node of its child, which is this, right? This is how we will just assign the value. Else if it is zero, it means it will be at the right position, so we will just assign this to right. So this new keyword is just that initially the left and right will be null according to this, right? This is the main thing. If you see here, this is the main thing. When we assign this, the left and the right part is null pointer. So we will assign this left to value child, and otherwise that is right. And we have done all the things, right? We have created one. Other if it is not, we have stored, and we have also uh, connect both of the parents and the ages, right? Now the main part is we have connected all the edges. Now how we will return the root node, how will I find the root node? So root node is never be a children, right? It what does it mean? It means this visitor child must not contains the root node, right? If it is actually a root node, so it will not be present in this visitor child. So what we will do, we will move in this all the nodes which is in this value node, and we will just started x with node value. Now what we need to do, we just started x which is node value, and if this x if this x value if this x value dot first value, which is the values of this node, right? If this value is present in my visitor child, if it is not present in my visitor child, it means it is a root node. So if it is not present in my visitor child, this will be must be a root node. So we will just return x dot second, right? This is what we do. This is what we do. So what we'll do, we will check for each and every value present in value node, because we have all the parents and the child node inserted in this. So if it is not available, if it is not available in visitor child, it means this is must be a root node. Otherwise we will just return a null, which will not be happen in this case, because in description the binary subscribed is valid. So this not be happen never. So we will return this x dot second, right? So this is how we solve this question. Let's just try to run this. uh, okay. Okay, this is a value node, not node value. Let's try to run this again. We have passed the sample case. Let's submit it. Yeah, we have passed all the test cases. So what will the time and the space complexity for this problem? So the time complexity is, the first thing is that we are iterating in whole of n description, right? So that must be of n. Second thing, this value node is also value node should also be iterating, right? So if you take value node as a o of n, which is all the nodes, so that must be o of n, right? So depends on how many nodes are there, right? So n is the number of nodes, right? Take this a number of nodes, and m is a take as size of description, right? Size of description. So that will be o of n plus m, right? Ultimately, that is o of n only, because this is something like depending on the age number of ages. So that will be o of n plus n. And also, so this size of description can be taken as e also, because this is representing ages, right? So number of ages is representing this number of descriptions, right? So this can be taken as number of ages. So that's why you can take as much whatever you want. So, and the space complexity would be, so first thing is unordered map. So each and every node has a mapping. So O of n for this for sure. The second, the visitor child. So again, visitor child can be O of n, because only one root node will not be there in visitor child. The third, nothing would be there. And this is unordered map. So this is a hash table. So it will not sorted in order. So that will not take O of n log n. So that will be O of n only. So this is how we solve this question. This is the time and the space complexity for this problem. Hope you get understand. Thank you so much. Bye bye.